This is a math question. Let's go ahead and solve it. Right off the bat, we know that this looks like it is a Laplace transform. So we have when the graph is equals to, or when the time between 0 and pi, we have this weird little thing, right? And then when it is more than pi, it becomes cosine t. Here, the t, this special t, denotes the greatest integer that is smaller than or equals to t. Greatest integer means whole number. So what does this mean? This basically means that when my t equals to 1, a equals to 1. When my t equals to 0.9, the greatest integer is actually 0. And then when it equals to 1.1, equals to 1, equals to, when it's equal to 2.9, equals to 2. So basically, it just takes the lowest whole number, essentially. So this is what this means. There's a special name for it, I forgot what it was, but let's just continue. So what does this mean? This means that, on hindsight, maybe because the t over here spans between 0, 1, 2, 3, and then 3.14 second, technically my t will equals to 0, and over here it will all equals to 0, and then over here my t will equals to 1, you know, for 1 more than less than 2. Or you know what, actually, let me write it out very clearly. So when my t equals to 0, okay, maybe I do 0, 1, 2, 3, 3.14, which is pi. Let's go ahead and write that my t equals to 0 from here to here. So basically 0 less than t, 0 less than equal to, more than equal to 0, you get it. My t equals to 0. And then over here, for 1 more than equals to t less than 2, my t equals to 1. And then 2 less than equals to 3 equals to 2. And then last but not least, we have 3, t less than 3 okay, instead of 3.14, I'm just going to write pi, since we all know what's happening, equals to 3. Okay, so as you can see, after writing it out, actually this, I didn't mean to click pencil, this becomes like an individual unit function on its own. But basically if I were to compile all these together, it becomes the original one that the question gives us. So with that being said, let's go ahead and write our unit, our function. So our function ft equals to, remember, it's basically equals to like the original function plus the delta, the difference in like the something like the new versus original times the unit step. Right, so we know that this is our template, and we have multiple different functions or expressions. So let's go ahead and just write that down. So originally we know that we start off with 0, so let's go ahead and write 0 plus 1 minus 0, 1 minus 0, and the unit step is basically t minus 1. Next one we have 2 minus 1, so we have 2 minus 1, unit step of 2. And then last but not least, we have 3 minus 2 times u over t minus 3. And of course we have to include this little guy, So we have plus cosine t minus 3, or is it minus pi? Ooh, I believe it's minus pi. No, it's minus 3, because the last t is actually 3, it's a whole number, so it have to be minus 3, not minus pi. Ah, that almost got me. Okay, and then this is just t minus pi, because it's pi onwards. Alright, let's go ahead and clean this up. I'm going to use a red color to make it more profound. So we have 1 minus 0 is just 1. So we have u plus 2 minus 1, same thing, is just 1. And then 3 minus 2, same thing, is just 1. Plus cosine minus 3, unfortunately it's not 1. Alright, and we have t minus pi. Right, I think it's quite simple to Laplace, except for the last one. So I'm just going to go ahead and just do the messy method. So this one, Laplace, I'm going to Laplace, okay. So this one, basically, there's a 1 in front, right? So the 1 is 1 over s times, then when you Laplace the unit step, it becomes minus alpha s. In this case, alpha is just 1, and plus, same thing, there's a 1 in front, so this alpha in this case is now 2, then plus 1 over s. Alpha in this case is now minus 3. Meant by the s. Right, over here, let's go ahead and let's go ahead and do this in a method that I'm more familiar with. So whenever I see a unit step, what I like to do is I like to write down the unit step first, like the Laplace version, and then I sub t plus alpha into my new equation, this equation. So it becomes, so technically I still have to do a Laplace form of cosine. My t now changed to this, so it becomes t plus alpha minus 3. One golden rule that you guys should take note of is whenever you see a cosine or sine, basically a trigonometry, and together with a pi, we're playing around with their waves, right? They're playing around the waves. So if I were to draw out a cosine wave right now, okay, maybe it's not that good. So something like, is it something like this, where this is a pi, and then this is 0, and then this is 2 pi. So as you can see, if I were to plus pi, it becomes minus 1, from 1 to minus 1. So basically it shift it completely by 90 degrees, which basically change the peak from a positive peak to a negative peak, or from a negative peak to a positive peak. So in this case, because it is a positive, so I have to change this to a negative peak. So we have negative cosine t minus 3. Let's go ahead and Laplace this thing right here. So I'm just going to use green. So we have this bugger times negative. So we know that cosine is basically sine over, s over s squared plus 1 minus 3, just a constant, is basically 1 over s times 3. Simplify it, it becomes 3 over s. And then there you have it. I'm just going to write everything out together. So fs equals to 1 over s, e minus s plus e minus 2s plus e minus 3s, minus, I can just bring out the minus sign, e minus this, and then it becomes s over s plus 1 plus 3 over 5. Sorry. Right, and there you have it. Laplace for a very special set function.